Hi, today we're going to do a virtual battery lab where we're going to build a battery like you might see in a cell phone or an electric vehicle like an electric school bus or an electric car. My name is Louie Dias. I'm the author of The Dragon-Powered School Bus, A Courageous Fight to Clean the Air, a children's book about a young boy with asthma who fights with along with his bus driver to educate their community about getting a new electric school bus to clean the air. And electric school buses need batteries, so we're going to learn how to make a battery. So to start off, you might have a paper guide that I created for this lab, but if you don't, that's okay. I'm just going to go through the guide step by step. Teachers, you can pause at any point to give students a little bit more time to finish a step or to maybe have a conversation about a question in the lab. So to find the lab, we're going to go to Google, and hopefully you have a computer that you can do this yourself as well. And the group that made this is called PHET. So type in PHET. This is going to be a DC battery circuit, so DC and lab. So PHET DC lab. I'm going to click return, and there it is, the very first thing. You can see mine's purple because I've already gone there. I'm going to click it, and it's going to take me to the PHET website made by the University of Colorado at Boulder. They created this so students could get practice and learn about some different things with electricity or science. And so this is it. If you see this, you found it. Click on the triangle, and that will load up the lab. And here we go. This is what it looks like. So let's get started. So building a basic circuit, and I'm just going to read right off of my lab sheet. Important stuff. Electricity is just the flow of electrons through a conductor, like a wire. When electrons flow, work can be done, like lighting a bulb or running a motor. And electrons are everywhere. And when electrons flow, then we say work can be done, like lighting a light bulb. Lightning is made of electrons. If you touch a doorknob and you get shocked, that's because electrons flowed really quickly because they were too built up on the doorknob, and so they wanted to kind of get away from each other and escape. So, all right, so step one, to add wire, click and drag a piece of wire from the toolbar. Okay, this over here on the left is the toolbar. So I'm going to click on the piece of wire, see how it pops up. I'm going to drag it over, and I'm going to drop it right there. Step two, add a second piece of wire and overlap the red circled ends. This connects the wire. So I'm going to go back to my toolbar, grab another piece of wire, and I'm going to connect it. And notice when the red circled ends come together, they snap together. So there we go. Step three, make a rectangle using 4 wires. Does electricity flow? So for electricity to flow, we have to complete a full circuit. Okay, so we have to make this go in a loop. So I'm going to connect this one here on this end. I'm going to drag that end, and I'm going to try to make a rectangle. I'm going to make this wire a little bit longer. There we go. And then I'm going to grab this one. I'm going to drag it down, and I need one more piece to make a full rectangle. There we go. Connect that there and do that there. And these little blue circles are my electrons. Notice they're not moving around. If there was flow, then the electrons will be moving. So there's a problem here. And what we need for electricity to flow is a source of power. Okay, so step 4, the circuit needs power. To break the circuit, click a connection point, that's one of those circles, and click the yellow scissors that appear. So I'm going to click this one right here. Notice the yellow scissors appear, so I'm going to click the scissors, and that breaks the circuit. And what I need is a battery. So I'm going to come over to my toolbar. I'm going to grab that battery, and I am going to connect it on one side. No, remember, we need to connect it on the other side. So now when I connect this side, let's see if electrons flow. Oh my gosh, they do, but too much. My battery's on fire. Okay, that's probably not a good thing. So let's go ahead and break the circuit. The reason that happened is that we need a source of resistance, or we need a load, something that's going to slow those electrons down. So that leads us to step 6. The circuit needs a resistor to slow the flow of electrons. So let's break apart the 2 wires, and step 7, drag a light bulb and connect the wire on both sides. Does it light up? Okay, so I'm going to put my light bulb right here. So I'm going to break the circuit, and I'm going to drag my light bulb over, and I'm going to connect it here. Notice there's another red circle. That means there's this wire connects there, and I'm going to do that because the way light is made is that electrons flow through the wire in the light bulb. This is a wire in there, and it's so thin that when electrons move through it, it heats up. It heats up super, super hot. If you've ever grabbed a light bulb, the old style light bulbs, what we call an incandescent, they get really hot, and that's what actually makes the light. So be careful with those, but that's what's going to make the light here, is the electrons flowing through and around our circuit. So here we go. I'm going to connect that, and we have light in our circuit. All right, that is success. Okay, so let's go to the next part, adjusting the light. Important stuff. Think about the power of a river. It depends on a couple of things: how much water there is and how fast it's flowing. A fast-flowing stream doesn't have much power if there's only a little water. Electricity is similar. The amount is measured in amps, A, and the speed is measured in volts, or V. Increase the amperage or the voltage, and you increase the power. Okay, so our step 8 here, click on the battery in the circuit. I'm going to click on the battery. A yellow box appears, you see down here, and a slider opens. Let's see. So step 9, we're going to adjust the slider. What happens to the amount of light? So the slider lets us adjust the amount of voltage, okay, or the speed of the electrons through there. If I slide to the right, I increase my voltage, and I increase the amount of light. Wow. Okay, so I'm going to set this to 60. That made for a much brighter light. Okay. What's the max voltage? Let's see how high we can go. Oh my gosh, the light's getting really bright. 120. So the highest is 120 volts. Okay, and actually the electricity in your house is 120 volts. So the light bulbs in your house are running at 120 volts usually. And that's where the electricity coming from the wires to your house is at. Okay. Number 10. Next to the slider, click the battery reverse icon with the 2 arrows. What happens? Which way do electrons always flow? So on our battery, we're going to click this battery reverse icon. Watch what happens to the flow of electrons when I click that. They run the opposite direction, don't they? So I'm going to go there. And the reason is that this orange end of the battery is the positive end. So the electrons always want to come into the positive end. Okay? So, let's see. Step 11. Adjust the battery to 60 volts. Okay, everybody adjust your battery back to 60 volts. So that I'm going to take my slider, I'm going to lower the voltage down to 60. Okay. Step 12. Add a second battery connect it to the first one. So right in a row. The two batteries are going to be right next to each other in a row. Make this one 60 volts too. What happens to the amount of light? So let's see if we can figure out whether there's more light with another battery. And the way we're going to figure that out is the light bars, look at that, they almost touch this toolbar on the right side. So let's break our circuit and let's put in a second battery attached to the first one. Now, remember, this was the positive end, and the black end of this battery is the negative end, so positive has to attach to negative with batteries. There we go. And when we connect that, aha, notice now our light extends actually through our toolbar on the right. So we're getting more light now. And I wonder what our total voltage is. So I'm going to click on that one. That one's at 60 volts. And that one's at 9 volts. And it says, make this one 60 volts also. So for the second one, let's also make that one 60 volts. Wow, those electrons are going super fast. All right, let's hope we don't light this battery on fire again. You probably could do that if you wanted to. You could adjust your voltage up enough that it would light again. So when we have two batteries in a row like this, we say they're connected in series. Okay, and we'll get back to that in a minute. Okay, next part. Part D, changing resistance in the circuit. So we can actually change how much resistance there is in the circuit. That would make the electrons flow more slowly, right? Because that word resist, kind of what it means, is going to push against the flow of electrons. You think we'll get more light or less light if we make more resistance in the circuit? Okay, well, we'll find out. So, step 13, break the wire and add a switch from the toolbar. Okay, so I am going to break the wire right here. And if this is like a light switch in your house, then we should have a light switch. So we're going to drag this over. This is a switch, and I'm going to connect this end there. I'm actually going to pull this like this, and I'm going to connect this wire. All right, we have no light because the switch is open. The electrons cannot go in a complete circuit. But if I click on that, I will close the switch, and there we go. That's like what happens in your house when you flip a light. When you flip the light on, you close that switch to make a complete circuit. When you flip the light off, you open or break the circuit so that electricity can't flow. That's what happens with every on-off switch for an electrical device. All right. Step 14, break the wire, add a resistor from the toolbar. What happens to the amount of light and why? Okay, so I'm going to break the circuit right here. And I like to keep things in like a square as much as possible. So I'm going to do this. And this over here is the resistor. Okay, it looks like a pill almost with some lines. And I'm going to drag that over. And I'm going to connect it in there. And I'm going to connect it on this side. Okay, let's do this. Okay, and what it's going to do is it's going to actually slow the flow of electrons. Now, we're going to click step 15. Click the resistor to show a slider. So I'm going to click that resistor, and I get another slider like I did for the battery, but this one's different. Instead of this being voltage and being able to change the voltage or the speed of electrons, we're going to change the resistance. And the effect is, well, let's see what the effect is. It says move the level up and down. What happens to the amount of light or electron flow? Why? What does it resist? All right, so let's take our slider, and when we increase it, oh my goodness, we slow the flow of electrons because we're resisting their flow, and that slows down the amount of light. Now, what happens when I put this maybe all the way to 0? All right, well then we're kind of to the max, right? So 0 resistance is the max flow of electrons. All right, part E, using a voltmeter. From the toolbox on the right side, drag the voltmeter out. Move each pointer to touch a different wire. What number do you see? So the voltmeter just measures the voltage in this circuit. So I'm going to put that there. And this is like a little metal pointer, and the little metal pointer can measure flow of electrons. So I'm going to click and drag this one to this side. I'm going to touch the wire there. And notice the voltage right now means question mark. It can't measure the voltage in this circuit because it's not touching it in two different places. If I do this, I need to do this on either side of the battery. So I'm going to put this red one on this side of the battery. And my voltage is 121 volts. Interesting. What was the voltage on each of these batteries? Well, let's click on this one. That voltage was 60. Let's click on the other one. That voltage is 61. So my voltmeter is measuring 121. When you have batteries in a row, what happens to the individual voltages of the batteries? What is the overall voltage? If this one's 61 and that one's 60, and my total is 121, that must mean we add the voltages of the batteries to make the total voltage. So I'm going to click that one to 60. And so let's go ahead and go to step 17. Make sure your two batteries are at 60 volts each. We just did that. Adjust your resistor to 0. What's the total voltage showing on the voltmeter? So yeah, the total speed or voltage is the combined voltages of the batteries. All right, so we did that part, and we said our resistor is 0. Is that true? Yeah, our resistor is 0 on the resistance. Okay, and step 18. Compare the total voltage to the voltage of each battery. The total voltage of the circuit is found by, is it adding or subtracting the voltage of each battery? All right, so we're figuring out how circuits work here. Step F, part F, conductor or insulator. Wire is a conductor, which means it's easy for electricity to move through it. The opposite of a conductor is an insulator. Electrons don't like to move through insulating materials. Wires are usually covered in a plastic layer. Since you don't get shocked when you touch it, plastic is right? Like notice there's plastic on this part that we hold for the voltmeter. Is that plastic a conductor, an insulator? Right, it's an insulator because electrons don't want to move through the plastic. They're going to move through the needle. That wire runs all the way through here, and there's a wire through here. So wires on the inside are carrying the electricity, and the plastic on the outside is preventing you from feeling that and getting a shock. All right. Step 20. In the left toolbar, click the down arrow to find new items. All right, so if we click over here on our toolbar, click the down arrow, we've got some more items, and we've got a dollar bill, a paper clip, a coin, an eraser. What else? A hand, a dog, and a pencil. Break the circuit and connect each item to see if electricity flows. If it flows, the item is a conductor. If not, it's an insulator. Items to test. So test the dollar bill, the coin, the paper clip, the eraser, and the dog. So to do that, we're going to break our circuit. And so for example, for the first one, I'm going to do the paperclip. Paperclip is made of metal, just like wire. Do you think electricity is going to flow through the paperclip if I conduct this? If I connect this? Let's see. Yeah, so is the paperclip a conductor or an insulator? If you said conductor, you're right. Good job. Okay, so go ahead and test all the other items. We can break that, remove the paperclip. We can just set it over there and drag those items one at a time to test. Okay. All right. Last part, G. This is our challenge. The batteries can be rearranged so that electricity can flow through one or the other. If one is disconnected, electrons can still flow through the other one. It's like a river splitting to go side by side and then merging back into one. This type of circuit is called parallel, instead of a series circuit like the one we've been using. So, last part of the problem, number 21, rewire the circuit in parallel instead of series. This means the power can go through one battery if the other is disconnected. What happens to the voltage of the circuit? So, this is our challenge. Can you redo your circuit so that these two batteries are side by side and the electricity is going to flow through either one? So let's start with them going side by side like that. And teachers, this might be a good place to stop. See if you can try making it so the electricity flows through both batteries at the same time. All right, give it a try. All right, I'm going to go ahead and do this, and you can see if you did it like me. I'm actually going to break that one, and let's get this. Let's move that out of the way. And let's do this. And I'm going to run new wires to there, and I'm going to run another piece of wire from there to there. So now the electrons can split, right? Like here's where my river splits into two. Let's do the same thing over here on this side. New piece of wire to there, and a new piece of wire to there, and oh, no electrons. Oh, I gotta finish my circuit. So let's do that. Let's connect this. Aha! And I have my electrons now split. Now let's see what happens. Remember, the total voltage of my whole circuit was 60 plus 60 because each of the batteries was 60, which gave me a total voltage of 120. And that was a circuit wired in series. Now let's test the voltage here and here. Interesting. My total voltage is now 60. So when I wire my circuit in parallel, it's the voltage of what each of the batteries is. We don't add it up anymore. But if we were to put in a different tool to measure the flow of electrons, to measure the amperage, we would see that the amps doubled now. Instead of the voltage doubling, the amps doubled when we do it like this. But that's getting a little bit advanced with our circuit. And so yeah, what happens to the voltage of the circuit compared to the voltage of a series circuit? The voltage is now half of what it was before. It's 60, right, to match the batteries. So keep playing with your circuit. Keep looking for different ways to arrange your batteries in different combinations and what happens to the amount of light. All right, thanks for joining me in our DC Circuit Lab. Check out all the great labs that are offered by the PHET website. You can do this at home, and it's a great way to learn about science. All right, guys. Thanks so much for joining me today, and have a good one.